Hey Steph, it is Thursday. So this is the first video I've made since you let me know that you are going down to once every 2 weeks making videos, which makes me a little bit sad, but I've got another project starting, so I'm going to tell you about it this week, and we'll see where it goes. For the time being, I'm going to keep going every week, just making video, updating you what's going on, telling you something interesting, and hopefully at some point, you'll be able to pick back up or make other videos for yourself or something like that. Because I know you'd said you were interested, and obviously things are a bit busy for you right now. So the new video series that I'm starting now this week is called Ask Rob. And in it, I'm going to take questions from the internet, from people, from friends, whatever, and I'm going to answer them. And I'm not putting any limit on the kinds of questions people can ask. I'm going to try to do one a week. We'll see how that goes. And so what I wanted to do this week is answer some of my own big questions, just whatever way I can, but these questions are really questions that don't have answers. They're just things that I always think about, and so I wanted to talk a bit about the question and why it's so difficult to answer some of them. So, how big is the universe? Wow, that's a really good question. The universe, there's no simple answer to that question. Basically, what we can see goes back about 14 billion years, and that means that we can see light that's about 14 billion light years away in every direction. And so at that point what we're seeing is basically the earliest stars in the universe, but that doesn't necessarily give you the whole picture. So a light year is a unit of distance, and it's the distance that light travels in 1 year. It's pretty simple to understand, but what's hard to understand is just how far a light year is. So the closest star that we can see, which is just a tiny little prick in the sky, is about 4 light years away. And stars don't get a lot closer than that unless they're in a pair system. Basically, to get a sense of how fast light travels, it can go around the Earth 7 times in a second. I mean, that's crazy. That's so fast. That's the speed limit of the universe as far as we know is the speed of light. So the simple answer is that the universe is at least about 30 billion light years across, but our way of measuring that is pretty simplistic. We can see about 14 billion years in every direction, and what we see is very, very, very young stars right from the beginning of the universe. And so if you multiply 14 by 2, you get 28 billion light years across. And so that's a small estimate for the size of the universe. But what we also know is that the space in the universe is expanding. That is a very tight lower bound on the size of the universe. There are estimates that it's as high as 50 billion light years across. And a light year is the amount of distance that light can travel in 1 year, and light is so fast that it can travel around the Earth 7 times in 1 second. So the universe is just absolutely gigantic. Every time I think about it, it just boggles my mind completely. How do I make my arm move? So this question is actually deceptively simple in that we don't have to think about our arm moving. You send a message from your brain to your hand, and your hand moves. You don't have to think about it. That's the beauty of it. But there is a very slight delay between you thinking hand move and your hand moving. Basically, that your arm moves because your brain generates signals, sends those signals as electrical pulses through your nerves to the muscles in your arm. The muscles in your arm will have some energy stored up from processing sugar into energy and will move your arm. It's a fairly simple process, but every time I think about it, it just boggles my mind. It's crazy. So how does light connect my phone to the internet? That's a good question too. If I go onto the internet, type in facebook.com, it loads pretty much instantaneously. That information that gives me Facebook was not on my phone a second ago. And so how it gets there, when you type that, your phone sends a radio signal either to a cell tower or to, in my case, the router that's in the next room, that says, give me this information from a website, facebook.com. I think the closest Facebook data center is in North Carolina. So basically what happens is there's some data stored on that server in North Carolina. It will send it through wires to, in this case, all the way to the next room. The router in there will basically turn this digital signal that was sent through the wire into a wave with varying height or a varying frequency, and that can transmit data as a string of ones and zeros that my phone will then get. It will receive these waves and interpret the ones and zeros and then convert it back into the original, in this case, Facebook. So the code, the computer code that my phone can read. And I don't know enough about network technology to know how that works, but all I know is in the last 100 years, we've come so far from basically discovering electricity and discovering light to cell phones that fit in our pocket and that just at blinding speed, like almost the speed of light, can get information from anywhere in the world, basically. Next question is, how does a baby grow into an adult? So that's another really good question. And it's something that we are starting to understand really well, but basically what starts out as one cell, the egg and the sperm, one cell each, combine their genetic material and then basically make one larger cell, which starts to split. And so once it's split a certain number of times, you have to realize that multiplying a number by 2 over and over again makes it get really big really fast. So it's not hard to imagine in 9 months it could get to 1 trillion. So basically the cell gets nutrients from at first the mom's womb and then through the umbilical cord. It gets enough nutrients that its cells are large enough to have 2 complete copies of themselves, and then the cell will just split. And so as the baby gets more and more nutrients, that keeps happening. The cells just keep splitting and keep differentiating based on genes, which are way too complicated to get into. And again, that baffles my mind that how much data is stored in our DNA. But basically, our DNA has a code on how to make a complete human being. So through biological machinery that's evolved over billions of years, our bodies can basically be fully formed from just this set of instructions and the set of nutrients from our mother. What if your parents just walked right past each other without ever meeting? This is actually really more of a thought experiment than a question, but it's a really interesting one nevertheless. It's crazy to think that if any little tiny detail was different, you wouldn't necessarily be you. You probably wouldn't be you. Every time people have sex, there are millions of sperm, and every one of them would lead to a slightly different child. And so it's not really an interesting question to think about how we are the specific us, but because we're narcissistic, that's how it comes out. Things happened the way they did, and so you have a result. So basically, if your parents walked right past another, you wouldn't have been born. But that doesn't necessarily mean that somebody wouldn't have been born. It just might not have been exactly you. It probably wouldn't have been exactly you. Something has to happen. Things keep happening, and the results of those things are what creates the world around us. There's not too much mystery to that. How quickly could the world as we know it end, just on a global scale, the whole world? Good question. So I can think of a number of ways that the world could just instantaneously end and none of us would have even been aware that it existed because we would just all cease to be here. But I'll talk about one specific way the world could just end instantaneously, all life on Earth gone within a few seconds. It's something called a gamma ray burst, which sounds like it's out of a comic book, and that's because it is out of comic books, but the gamma ray burst I'm talking about is about 1,000,000 times brighter than something that would give you, say, fictional superpowers. So when a star collapses on itself and turns into a black hole at the end of its life, or turns into whatever it's going to turn into, be it a neutron star, dwarf star, whatever, it collapses and jets of light come out of the top and bottom, the poles of the star. Even if the star can be light years away from us, like literally a dot in the sky, but if it sends out one of those jets as it's dying, we are not really going to know about it until it hits us, because that jet of light is going to travel at the speed of light, and this collapse happens really, really quickly. So we might get a couple hours. We would notice that the star is unstable, that it's at the end of its life, but we really would have no way of avoiding getting hit by this gamma ray burst. And it would basically incinerate everything on the surface of the Earth. at least on half of it, but the other half would be completely devastated, and basically the atmosphere would be burned off. Nothing would survive. Instantaneously, everything would be gone. It's crazy to think about that. It's really, really unlikely, and we haven't had it happen so far, but there have been theories that one of the mass extinctions was actually caused by one of these gamma ray bursts just shaving past Earth. So we got kind of the outer edge of it, a much weaker burst. Lots of things went extinct, but the world didn't completely end. Kind of depressing, but crazy to think about. So if we could harness all of the sun's light, what could we do? So this is something that has been thought about for quite some time in science fiction and by actual scientists. Basically what you'd have is what's called the Dyson sphere. If you're able to capture all of the light from the sun, basically a Dyson sphere is when you'd have some kind of technology that would basically encircle the entire sun, gather up all the energy that it is letting out as light and as radiation. Basically the light that hits us every minute is enough to power humanity much, much more than a minute. Like we get hit by enough energy several orders of magnitude over what we need to function as a society with electricity and with light and all that stuff. So to think about what we could do if we had the energy of the entire sun, literally a massive million Earth weight nuclear furnace, is just almost inconceivable. We could do anything. Like space travel would be nothing. We wouldn't need batteries ever because our electrical grid would constantly be overpowered. It would just be insane. There is basically no limit to the technology we could have if we could harness all of the light from the sun. There would be no energy shortage, there'd be no crisis, we would have electric cars everywhere, everything would run on electricity, and everything would run forever. It would be so great. And there's been talk about, not necessarily doing it, but there's even been talk about putting up enough solar panels to actually get enough energy for the Earth to run itself, which would be so cool. I think that we could theoretically do this within our lifetimes, but man, that'd be cool. Just not having to worry about energy, not having to worry about natural gas, climate change, all of that. Be so cool. Really cool. So why do we age? And then after that, why do we die? Couldn't you just have life go on forever? That's a cool question. And it's actually kind of interesting. So basically, there are certain organisms, there are certain jellyfish, I believe, and that don't die. Now, there are problems with that. Specifically for humans, there are big problems with that, and that is that our cells get damaged all the time. And sometimes they get damaged faster than we can regenerate them. And so that's called cancer. When a cell becomes cancerous, basically it starts to replicate out of control because the defenses that cause our cells to die off normally to keep us normal the way we are broken. And so to counteract that, our cells are programmed to only last a certain length of time. They only last a certain number of replications. There are mechanisms in our cells called telomeres, which basically every time a cell replicates, a little bit gets chopped off, and when too much gets chopped off, the cell just dies. When the telomeres get too short, the cell just doesn't work anymore. And it's programmed cell death. It's called apoptosis, and it's perfectly normal, and it's happening throughout our bodies all the time. So that is a good thing. The purpose of life is to procreate, to regenerate itself in a new form, not to, once humans specifically have reached reproductive age, they've reproduced, they've raised their children to the point that they're self-sufficient, that's all we've been designed to do. That's all evolution has done for us. It has let us survive long enough to reproduce and to raise our kids to the point that they're self-sufficient. And so after that, we don't need to be alive. There are things that do damage to us that cause us not to be able to live forever, right now anyways. That comes out in us getting older and eventually dying, because it wouldn't be a very good mechanism if there were just a bunch of very old, degenerated people walking around. Biological material on Earth would get run out really, really quickly if stuff didn't die. We need that cycle to keep going in order for life to keep going and to be refreshed and renewed, and that's why the metaphor of the phoenix is so cool. On that note, how does evolution work? Okay, well that's a question that I can't answer in a couple minutes, but I'll try to give a little history of evolution. So basically, evolution is... Oh man. Never say the phrase, so basically evolution is. because it's not going to go well. The explanation is going to take longer than so basically. Every generation of people adapt to their environment. For instance, we've been wearing clothes for a while, and so we lose a lot of our body hair because we get rid of it because we don't need it, because we're warm enough without it. Things like fingernails grow, hair itself grows, our eyes get better, our ears become attuned to different frequencies, all kinds of stuff. This has all evolved over generations to better adapt us to our current environment. And so if the environmental changes stay for long enough, we adapt to them. And evolution is that process over 1,000 generations. So you're not going to see evolution on a generation-to-generation basis, but after 1,000 evolutions, you'll notice that suddenly we're not monkeys anymore. Not suddenly, but if you skipped 1,000 or 10,000 or 100,000 or a million generations, you'd notice that the organism was different. But the changes aren't big in a given generation. They add up over time. So this is an interesting question that was raised to me. What if there is a species of alien somewhere in the universe that is so powerful and large and immense that they basically don't even notice that we're here? The analogy that I've heard is, what if we are just ants on the side of the road to aliens? So that's a really cool question. Basically, what if there's a civilization so advanced and so large in scale and in size that they don't even notice that we exist? And so they're literally all around us, but we can't even perceive them, and they don't care about us. Honestly, I think we would notice if that were happening. I'd like to say that we can say for sure that that's not happening. We understand quite a bit about the scale of the universe, but at the same time, there's a lot of stuff going on at the cellular level that is completely foreign to most of us. If you're not in microbiology, you'd have no idea what's going on down there, and there's just crazy stuff going on. If you've ever watched cell mechanics, computer graphic representation of cell mechanics is just crazy. Like, it's absolutely unbelievable that kind of stuff happens on such a small scale. And so it's not inconceivable to think that something could be happening on several magnitudes of size larger, but we have some pretty good telescopes. We can see far out. And from what we can see, I don't think it's really that plausible there are organisms that are that much more advanced and that much larger than us that they wouldn't even notice us. But it's an interesting question nevertheless. So those are my questions. I hope they got you thinking. They always get me thinking. If you have a question that you think is interesting or something that you are constantly thinking about, please send it to me. Go to rob@trell.com. You will see a link on the left side of the page. It says Ask Rob. Go click on it. There's a form there. You can ask me a question. You can send me an email. Send me a message. Yeah, my contact information is all over the web, so you shouldn't have, if you found this video, you shouldn't have trouble asking me a question. But yeah, rob@trell.com is the way to go. I would love to answer your questions, and I'll try to take one a week. Anyway, Steph, I guess you're not making a video next week, but I will see you the week after. I love you. Bye.